Bueno, pues vamos a empezar la presentación. Buenas tardes a todos. Mi nombre es Tania Basail Basso, de Softwood Export Council México. El día de hoy tendremos 4 presentaciones pequeñas en donde hablaremos sobre mass timber. La primera presentación será impartida por David Parcell, que nos dará una pequeña introducción sobre este tema. David, thank you very much for being here and for your time. As I said, David is going to present an introduction of mass timber. Thank you very much, David.
Thanks, Tanya. I'm just going to try and bring up my screen. If I can be successful with that, we'll see. All right, can you see my screen? Somebody shake your head, yes, there. Thank you very much. All right, so thank you everybody for attending this morning. I'd also like to thank Manuel and Kamako for the invitation to present our webinar today. Also like to thank Tanya and Rose from Softwood Export Council for the coordination effort to put this whole thing together for us. I'm David Parcell. I work with the Forest Business Network. FBN produces the annual International Mass Timber Conference. This particular year, 2021, as a lot of conferences around the world, we did our conference virtually for the first time. We are looking forward to a in-person conference back in Portland in 2022. I believe we're scheduled for the middle of April. We'd certainly like to see any of you that have an interest in mass timber to join us there for that. We also produce the International Mass Timber Report, which is the basis for the presentation, the information you're going to see today. The International Mass Timber Report looks like that. This year, the 2021 version is almost 250 pages of information and data on the mass timber industry, both in North America and around the world. A little bit later on, I'm going to have a slide that will have a link. If you're interested, there will be a free download of this year, the 2021 Mass Timber Report that you can access. So I'll show you that here in a little bit. So we certainly encourage you to gather that information if you have an interest in the mass timber industry. So with that, the agenda for today's presentation, essentially we're starting with a welcome, which is what we're doing now. I'm going to do quick introductions of the 3 presenters today, and the presentations that they're going to be making are the North American State of the Industry presentation, the global perspective on mass timber, and then the third presentation is, could mass timber save the world, and can we afford it? Then we're going to follow with maybe some short panel discussion and live Q&A to answer whatever questions you all might have. So with that, our 3 presenters today are Roy Anderson. He's a vice president with the Beck Group. Lech Mizynski is a professor with Oregon State University. And Emily Dawson is a partner and principal architect with Kaiser and Path, one of the leading architecture firms doing business in the mass timber world. And I'm sure Emily will talk a little bit about some of the many projects that they've done in her presentation. I'll give you a little bit more information on each of them as I introduce their specific presentations here in a little bit. Before we get to those presentations, however, I did want to just touch on a very high level, why mass timber? You know, a lot of the information you're going to get today is what mass timber is, how they make it, you know, what the capacities are, the facilities around the world, a lot of detailed information on that. But I wanted to start and kind of create a foundation as to why we think mass timber is so important. And again, this is going to be very high level. There may be some more detailed information on some of these topics throughout the rest of this morning's presentation, but I did want to touch on this to kind of set the basis for today's conversation. So to start with, mass timber is the only renewable resource of the 3 major manufacturing products that are used in major construction, the alternatives being concrete and steel. Second reason that mass timber has an advantage is the speed of construction. And I think Emily will get into this a little bit later on, but you can essentially put up a mass timber building much quicker than you can build a similar building either out of concrete and steel. And that has some advantages in cost and various other things. The construction using mass timber is also very efficient. a lot of the actual work in preparing the material is done in a factory somewhere. So a lot of the labor source is transferred off of the job site. So that leads to fewer people on the job site, the speed of construction, the construction happens faster on the job site. That reduces risk for the builder and for the developer, the job site risk. There's a number of enhanced product performance criteria that we probably won't get into today, but essentially a wood building has more aesthetic appeal than a comparable concrete and steel building. Michael Green, one of the famous architects doing a lot of work in the mass timber business, I recall him making the comment at a TED Talk seminar, something to the effect that he's never seen anybody walk into one of his buildings and hug a steel column, but he has actually seen that in one of his mass timber buildings. So I think that's kind of an interesting perspective. But beyond the aesthetic appeal, mass timber has a variety of other benefits. There's insulation benefits, both sound and energy. So there's a variety of conservation benefits. There's data that proves that mass timber buildings create a more productive environment, whether it's business, whether it's school, whether it's hospitals. There's a more productive environment created using wood as the primary material in a building. And in today's COVID world, there's data that suggests that wood buildings create a healthier environment as well. So again, I don't believe we're going to get into a lot of detail on those things, but I did want to share that there are benefits using mass timber, just enhanced product performance benefits. And then the final thing I'm going to touch on, and I will share just a little bit of detail on, is the climate change and carbon considerations, because I think this is absolutely critical. And it's one of the reasons that we're all very enthusiastic about mass timber as a construction material. So when I first saw this graphic a couple of years ago at the Mass Timber Conference in Portland, frankly, I was very surprised. You know, we spend a lot of time in the media and in legislation and things like that in the United States, and I think around the world, focused on carbon emissions from automobiles in the transportation sector, and then secondarily, carbon emissions from the energy sector and the industrial sector. And what this chart shows is, you know, the building sector actually represents half of the emissions, global carbon emissions around the world, essentially equivalent to those other two categories where we spend all of our time and our energy. So I think that was extremely surprising to me. And then if you think about trying to solve those problems, the technological challenges to solving the emissions through the transportation sector and the energy sector are daunting. Whereas in the building sector, we have a potential solution for a significant portion of the carbon emissions related to the building sector. So this next slide, and I apologize for the graphic, you may not be able to read it, I get that, but I wanted to share this as a way of talking about the advantages, the carbon advantages of mass timber over the alternative materials, specifically concrete and steel. If you get a chance to, and we can certainly share this presentation with you later, if you get a chance to take a closer look at it, that would be fine. But what I've done is I've summarized what's the information that's in the graphic underneath the graphic. And the net outcome of this is that a metric ton of concrete, the net emissions to produce that concrete is about a metric ton of carbon that is required to produce a metric ton of concrete. Steel is a much dirtier production process, and there is no carbon sequestration benefit to steel. So essentially, for every metric ton of steel used in construction, you're looking at 2.25 to almost 3 metric tons of carbon emission, you know, in the production process. Mass timber, at the end of the day, mass timber actually sequesters more carbon than is required to produce that mass timber. So a metric ton of mass timber produces less than a metric or half a metric ton of carbon in the process of producing it, but it also sequesters up to 2 metric tons of carbon in the finished product. So at the end of the day, building with mass timber actually extracts carbon from the atmosphere. That is an absolutely huge game changer in the world of climate change, as you can imagine. So just to quickly summarize kind of what I believe are the benefits of increasing the use of mass timber over the alternative materials. One is, at the end of the day, we can improve forest health. And that's always been a focus of Forest Business Network. It's one of the reasons that I am so actively working with Forest Business Network, because I am passionately committed to improving forest health. Part of the outcome of improving forest health are a reduction of fire danger. Mass timber can use a lot of fiber out of the forest that doesn't have any commercial value elsewhere. We use small diameter timber, things like that, so we can reduce the fuel load and reduce the incidence of fire, and specifically catastrophic wildfire, which has been in the news in such a big way in the last 5 or 10 years or so. Obviously, improved forest health also protects water resources. I know in the US, it's about 70% of clean water comes through the forest. And therefore, better forest means protection of those clean water resources. It also means improved wildlife habitat, which is important to an awful lot of us. Another benefit is by increasing the use of mass timber, we improve the rural economic activity. We put more people to work in those rural communities. And as we've already talked a little bit about, the reduction of carbon emissions in the building sector, is a big bonus. And finally, the sequestration of carbon, taking some of that carbon out of the atmosphere, can have a huge benefit in the climate change equation. We have the ability as an industry to have an impact on climate change moving forward by substituting mass timber for concrete and steel in the construction process. So here's that link to the free download of the mass timber report. I will post this link into the chat box, so you'll be able to just copy and paste it in and use that in the future if you'd like a copy. With that, I think we're going to take a jump over and introduce Roy, who will be doing his presentation. So I'm going to stop sharing here if I can pull it off. There we go. So up next is Roy. He's going to be doing his presentation. A little bit of background on Roy. He's got more than 30 years in the forestry and forest products industry experience, including completion of several CLT manufacturing feasibility studies. He spoke on mass timber at the initial International Mass Timber Conference in 2016 and has been a partner in the International Mass Timber Report for the 3-year run that we've been producing that. So Roy, you're up.
All right, thank you, David. And I think everybody can see my screen. Just let me know. Yep. All right.
Yes.
And thanks for the opportunity to speak to your group today. I'm happy to do it. And I will talk about some of the information that's in our report, but I have a few kind of introductory slides that just talk about what mass timber is and how it's used, just in case people aren't familiar with that. But before I get into that, I just want to take a minute and talk about the company that I work for. It's the Beck Group. The company has been in business about 40 years. In fact, we're going to have a 40-year celebration coming up this summer, which I think, you know, we're not a big company. There's only about 5 or 6 of us working right now. And we're proud that we've been in business for 40 years. Most of our clients are forest products manufacturers. And, you know, we deal with them on a daily basis. But what I don't deal with on a daily basis is mass timber. Like David said, for the last 3 years, I've been part of the team that writes the International Mass Timber Report. So what happens is usually about for a month, 1 or 2 months every year, I take this deep dive into mass timber and kind of catch back up to speed on what the latest developments are. And what I hope to do today is pass along some of the things that I've learned from doing that. So that's a little bit about the Beck Group. I've been with the Beck Group for 15 years. So, and we're in Portland, Oregon. Okay, so just like I said, a few slides about what mass timber is. And for me personally, when I hear mass timber, my mind instantly goes to cross-laminated timber. And that's what you see in this picture right here, where you build basically a big panel that might be anywhere from 8 to 12 feet wide and up to 40 feet long, and as much as 1 foot thick. But that panel, excuse me, if you think about it, it's similar to a plywood panel where you have the, in plywood, the layers of the veneer, the grain is oriented perpendicular to each other in each layer. Well, it's the same thing with cross-laminated timber, except instead of veneer, it's pieces of lumber that are glued together. So that's CLT. But it's not, mass timber is actually a whole family of products, and nail laminated timber, or NLT, is another product in the group. And you can see here, it's a very simple process of you just take lumber, stack it up vertically next to each other, and then each layer is nailed together. And a few advantages of that are that, it's typically built right on site. CLT, like I was talking about a minute ago, is made in a factory, but NLT is made right at the site where it's going to be, put into use. So that's an advantage, and it's often used in, as a floor or a ceiling in a building is kind of the most common use of NLT. This one is dowel laminated timber, or DLT, and you can see in this picture the boards. Can you see my cursor when I move it? Okay, so the boards are oriented vertically just like NLT, but you can see instead of nails being used to hold the pieces together, these are wooden dowels. And if any of you are wood technology type people, I think this is really a cool thing about this. This lumber that makes up the panel itself is usually about 12 to 14% moisture, or 15% moisture, somewhere in that range. These dowels are made out of hardwood, and they're dried down to about like 7% moisture. And so when they're placed into the panel, these are drier than this, and it picks up moisture and swells. And so it forms a really tight fit there. And so the whole thing is held together with no adhesives or anything. It's just the dowels and using wood's relationship to moisture for holding it all together. So I think that's a pretty cool thing about that. And then another advantage of it is if you ever have to do any machining on it or anything like that, since it's all wood, whatever kinds of cutting tools you have, you don't have to worry about running into nails or anything like that. So another one is mass plywood panels. Right now there's only one manufacturer of this product in the world, and that happens to also be in Oregon, where I'm at. But here the panels are made out of veneer, and usually they're all, each layer, the grain is going the same direction, so it's not quite like plywood. It's kind of more like an LVL product. But this company that manufactures this product is called Freris Lumber, and like I said, they're the only manufacturer of it in the world, and they can make panels. Right now they're certified to make panels out of this that are 12 inches thick, I believe up to 12 feet wide and 48 feet long. So a massive panel all made out of veneer, and their press actually can manufacture panels up to 24 inches thick, but they just don't have the certifications completed for that yet. So that's coming in the future for this product. Another type of mass timber is actually one that's been around for a long time, glue laminated timber, and that's what you see in these pictures. And this one right here, I believe the dimensions on it are 24 inches by 24 inches. And I believe those particular glue-lam timbers were going to be used in a building in Milwaukee, Wisconsin. That's going to be 25, it's all wood, It's under construction right now, and it's 25 stories tall. And so these pieces that you see right here were going to be used in that building. Just massive pieces of wood. The picture doesn't really do it justice when you're standing right next to it. It's pretty amazing how big a piece of timber that is. But glulam is also comes in curved varieties, and it's basically used as columns or horizontal beams in buildings. So now I want to switch gears a little bit and talk about how mass timber is used. And I don't believe this picture I have here is a mock-up. It's not a building that's actually been constructed, I believe. I'm not sure about that, but I think that's the case. But the reason I used it is because it really shows all the different ways that mass timber can be used just in one picture. So you see the vertical pieces here. Those are glulam timbers that are used as vertical supports in the building. You know, the floors and the ceilings are the panels that could be CLT, mass plywood panels, could be DLT, could even be NLT, but you know, that's typically used in a horizontal application as a floor or ceiling. In some buildings, the walls may even be made out of CLT, but that's not shown here. And then I believe these would be very large GLT pieces, but they might also be just massive panels as well. But the point is, you know, there's a variety of different ways that mass timber is used in buildings. And I think Lek and Emily are going to talk more about that. So I want to shift gears and talk about some ways that mass timber is used that you really never hear a lot about in the press or just really anywhere. But there's some companies that are making mass timber that is used for non-structural applications. And so that's what you see in the, well, I should say in non-building applications. But what you see in this picture right here, you know, this is mass or CLT, both of these pieces. And normally this is called shoring. And that would, you know, they put it down in a ditch or trench or whatever is being dug. And that way workers can be down in there and avoid, you know, having the walls of the trench collapse on them. Normally a product like this would be made out of steel. And so it's very heavy and you need big equipment to move it around. But one advantage of making this kind of product out of CLT is it's much lighter and you can have much, you know, lighter, less expensive equipment to be able to move the pieces around. And then even another form of this, instead of having the panels connected by these cross members, they would drive I-beams into the ground on each end, and then the panel slides down in between the I-beams. And one advantage of that is you can also, you know, if you're done, you can pull the panel out and lay it on the ground. And if you need, you know, some ground cover or to be able to move equipment across a piece of ground, it just gives you a lot of versatility to be able to do that. So that's, you know, one way that mass timber is being used in non-building applications. Another one here is this picture. This is a bridge deck that's made out of wood, and you can tell from the green color that it's been treated with some kind of copper preservative. And I think that's a great new development for mass timber. And I talked to the manufacturer of these panels. Each one of these is 4 feet wide, and that was done intentionally because when you treat wood, a lot of the cylinders, the pressure treating cylinders, are about 6 feet wide. And so you can, you know, by making these panels 4 feet wide, you can put a whole panel into the treating cylinder or a stack of them, and you're able to treat, you know, the panels with wood preservative, and then they can be used in these outdoor applications, like in this particular case, this bridge deck. But they're also being used as sound barriers along highways and as retaining walls. So with the ability to preservative treat the panels, you can start, it opens up a whole new world of applications. So I'm actually kind of almost more excited about some of these applications than some of the building things that you see and hear so much about. This is another example of some, non-building applications. Here, the panels are being used basically to create a temporary roadway to access, land that would be hard to get to with equipment if you didn't have some kind of temporary road down to let, big equipment move across it without damaging the soil. So you see it a lot along utility corridors like these two pictures show, or you see it used like in mining and oil and gas drilling applications where they're moving big equipment around, sometimes sensitive areas and soils. And so they'll lay down these temporary roads that are made out of mass timber. So those are a lot of the ways that mass timber is used. And I'm going to shift gears again now and get into some information that's contained in the report that David mentioned that's available to all of you. And like I said, I've been working on that report for 3 years, and it keeps evolving, and new information keeps being added. And I think it's a great resource. So I encourage you to download it and take a look at it. But when the way that report is organized and the way that my mind works to try and help me think about mass timber, I always think of this supply chain that you see in this slide. And it really starts with the forest resource. Then it goes to the raw materials that come out of the forest. So I'm talking about logs and lumber and veneer. And those things then go on to the mass timber manufacturers who make the different kinds of mass timber that I just talked about. And then there's architects and designers and engineers that specify how it's going to be used in a building. And then construction companies come along and make it. And finally, people are living and working in mass timber buildings. So it's this whole kind of process that happens. And like I said, I always kind of reference back to this as a way to help me organize my thoughts when I'm thinking about mass timber and how the whole industry functions. But in the next few slides that I'm going to go through, I'm just going to talk about these particular sectors right here. The forest resource, some of the raw materials that go into making mass timber, and then kind of the state of the mass timber manufacturers that are operating in North America right now. So first, regarding the forest resource in the US and Canada, that's one other thing I should mention. Most of the, this report focuses heavily on US and Canada. And so most of the information that I have references the US and Canada, but for this particular slide, I was able to find the number of forested acres in Mexico. So I added that. But really, in the US and in Canada, the amount of forested land is pretty similar, about 820 to 860 million acres roughly. And in each country, that's about 1/3 of the total land area is forest. And Mexico has 160 million acres. So if you add it all up, it's about 1.8 billion acres of forest in North America. And again, I don't know the details about Mexico, but it's roughly 1/3 of the land area is forested. And that hasn't really changed for well over 100 years. So the amount of land that we have as forest has been really stable for a long time. And I find that's good news in my mind. That's encouraging to a lot of people because you hear so much about, destruction of forests and things like that. But at least for North America, that has been stable for a long time. But it also raises the question, well, if the area of forest land has been stable, what's really happening to the trees that's on that land? And one concept that foresters use to measure sustainability is called growth to drain. And so each year, if you have, for example, 1 acre of forest, it's able to grow so much volume. And then also if, a tree dies on that acre, or somebody cuts down one tree, then you've taken away a certain amount of volume. And that ratio is called growth drain. And so long as the amount of growth is greater than the amount of drain, which could be harvest, or it could be just natural mortality from fires or insects or disease or whatever. So long as that ratio is greater than 1, then you can really have a perpetual forest, because the amount of fiber that's there is either staying the same or increasing over time. And so if you look at the bottom row of this table, that's what that ratio is for the United States. And on the top 2 rows are the amount that just dies naturally from insects or disease. This is all in cubic feet. This row right here is the amount that's harvested. And then this is just the combination of those two in this row. And then this is the bottom is the amount that grows. And I guess one thing I would point out here is, the amount of harvest it bounces around a little bit, 14, I guess, billion cubic feet in 1976, but here we are in 2016, and we actually harvested less timber in 2016 than we did in 1976. But what's changing is that you see annual mortality is really on the increase, on the rise. And I would say that's mostly happening in Western forests in the United States, where we've had a lot of wildfire, we've had drought, we've had large outbreaks of insects and disease that have affected thousands and millions of acres of forest. So it's really, the reason you see this ratio dropping isn't because we're harvesting more trees, it's more that trees are just dying naturally for a variety of different reasons. So that was the US. They measure the same kinds of things in Canada, and you can see there the ratios are even higher. And the chart is flipped, so on the years are going down the side on this one compared to the prior chart. But it really shows that actually Canada on the whole is in a stronger position than the United States. They're actually adding more fiber each year than we are in the United States. But I would say one exception to that is in Western Canada, especially British Columbia, where they had a large outbreak, a very large outbreak of beetle attack that killed a lot of trees, and they had to salvage as much as they could, but they went into mass salvage mode, and that means now they have to put a pause on harvesting more trees in that region to give the forest time to catch back up. So that's just some highlights about the forest resource, but I think the key pieces of information that you can take away are: 1, the amount of forest has been stable for years in both the United States and Canada. There's more trees growing each year than are being removed either by harvesting or natural mortality. And then again, specifically in the Western US, there's a lot of standing timber volume that's just not available because of policy issues in the way that publicly owned land is being managed. So I'm talking about national forests and the Bureau of Land Management, and in some cases state-owned lands. So there could be even more trees harvested and we'd still be at sustainable levels, but it's just that some of the standing timber that's out there just isn't available for it, and it's because of administrative reasons. So that was the forest resource. If you think back to that supply chain graphic that I showed you, I'm going to switch gears now and start talking about lumber, because that's one of the key raw materials in manufacturing mass timber. And when you see lumber production reported, it's usually referenced back to these different regions. So that's why I just wanted to throw this map up here so you can kind of, in the next few slides, it talks about production and things in certain regions, and it's based on this kind of breakdown right here. So this shows from 2000 to 2020, it shows a few different things. And let me talk about that. So the first thing I want to point out is this blue line here is the level of housing starts in the United States. And then the top of the bar charts is the total amount of lumber produced in all of North America. And the bar graphs reference this axis, and then the housing starts reference the right-hand axis. So we went from a peak of just over 2 million housing starts in 2005, and then we dropped down to, you know, close to 500,000 housing starts in the bottom of the Great Recession. But what you can see is lumber production really follows closely with housing starts. I mean, that's no secret, or probably not very, that's not really news to a lot of you if you know much about the lumber industry. But I think where a lot of people, when you start talking about mass timber, where the question starts to arise, well, if lumber production is so closely matched to housing starts, what happens when all of a sudden you have this brand new demand for lumber that's caused by mass timber? Because most mass timber up to this point has been used in non-residential construction. And so the question really starts to arise is like, how much capacity do we have to produce lumber in sawmills? And like I was talking about a few minutes ago, how much can forests provide, you know, more raw material to make more lumber? So, and I have some more slides coming up that address that, but those are some things that you start to think about when you start looking at a graph like this. And one other thing I want to point out real quick is this kind of reddish color is the amount of production that has happened in the US South. And for a long time, the US West, which is this purple color, I guess it is, and the US South were about even. But then coming out of the Great Recession, the US West has just been flat for almost 10 years now. And the US South just keeps growing in the amount of lumber that they're producing. And again, that goes back to, in the West, a high percentage of the land is publicly owned, and current policy just constrains how much timber is harvested from the public lands. So we're kind of capped in the amount of logs that are available to sawmills in the US West. But in the US South, in recent years, there's been about $5 billion board feet of capacity, sawmilling capacity added in the US South. So that's why you see the South taking ever more larger share of the production of softwood lumber. One last thing on this slide is I didn't calculate an average, but I would say over this 20-year period, you know, we're looking at roughly 60 billion board feet of lumber consumed each year in the United States. One thing that happened in 2020 and 2021 that's had a big impact on mass timber is what's happened to the price of lumber. And that's what's shown in this chart right here. This is the framing lumber composite price as reported by Random Lengths. And you can see it's the long-term average, I think, was around $350 a thousand, like from this period through this period. But then we've just seen a massive spike in lumber prices, and it's mainly driven because of COVID. You know, at first, a lot of people were staying home and doing remodeling projects, and demand for lumber went up. And then at the same time, all of the sawmills are to this, well, when COVID first hit and even through right now, they just cannot get enough labor to, you know, run more shifts at the sawmills. And so demand is up and supply or production can't keep pace. And so you see this trend in prices. but it's had a real negative impact on mass timber manufacturers because, at least the ones in North America, because you didn't see the same run up in prices in Europe. That's slowly starting to happen more recently, but for a long time you didn't have that. So the mass timber manufacturers in Europe, you know, they're able to get their lumber at a lower cost, and the US and Canadian mass timber manufacturers just couldn't compete with that. So you see a lot of mass timber being imported from Europe into North America over the last year and a half or two. So some key takeaways about that. You know, I mentioned US and Canadian sawmills produce about 60 billion board feet a year. That's mostly been used linked to housing, whether it's new housing or repair and remodeling. And so a question is, well, if mass timber really takes off, can we produce more than 60 billion board feet of lumber a year? And I still have one slide coming up that addresses that. And that's because, like I mentioned, mass timber would be a major new consumer of softwood lumber. And I talked about the big run up in prices for lumber and how that's affected North American manufacturers. So now I've only got a couple slides left. I think three or four, but I'm going to switch gears again and talk about how mass timber is manufactured. And I know Lek, who's going to go after me, goes into a lot more detail on this. But this basically shows a mass timber manufacturing plant. I'm not going to go into a lot of detail, but I want to point out a couple things. Just the basic flow of material. It starts out right here with incoming units of lumber, and then it moves basically through the whole process and comes out the other end as a mass, as a panel of mass timber. And everything I've seen up to this point, people talk about the capacity to manufacture mass timber based on the throughput of the press. And in this diagram here, this number 12 is the press. But I think we need to come up with a better way because of expressing capacity, because when I start talking to the manufacturers, they say the press is actually not the bottleneck in their plant. In other words, other parts of the plant can't keep up with the press. And so the output of the whole plant is really limited to some other function. So to me, it doesn't make sense that you talk about the capacity of the plant when in reference to the press. And really what the bottleneck is the ability to CNC the panels once they're done. So cutting out, channels for utilities or plumbing or windows and doors and things like that. That all happens after the panels are pressed, and that's done with CNC machines. And my understanding of it is that the CNC machines are we need more capacity to do that. And so that's really the term I use is the bottleneck in the ability to put out mass timber panels. Excuse me. Right now, there's 15 plants that are operating in North America, and those are shown by the green dots. And it's interesting to me that, there's this cluster right up here in kind of the inland west, the mountain inland west. And I believe the reason for that is in that particular location, you have access to Douglas fir and spruce pine fir lumber. And so Douglas fir tends to be a darker color, and some people prefer that, but then others prefer a lighter color that you'd find with an SPF type lumber mix. And so if you're right in this region, you can access both types of lumber. So I think that's why you see a big cluster there. And then down in the south, especially, and right here, those plants, at least historically, have focused more on producing mass timber that's used in non-building applications. So like I talked about earlier, matting, to go along utility rights of way and things like that. So that's kind of the way things stand right now. This one is a blue one. At the time I put this map together, this was a plant in Conway, Arkansas that was under construction, but they recently completed construction and are now starting operations. There's these pink ones are plants that are under development. This one for sure is under development in Columbia Falls, Montana. And then these two, I'm being kind of speculative, but Binderholz is a big company that's in Europe that makes mass timber. They recently purchased 2 sawmills, one in Florida and one in North Carolina, that were in bankruptcy. And everybody thinks, well, the reason they purchased those sawmills is because they're going to put mass timber plants adjacent to those sawmills. So it remains to be seen if mass timber plants will be built there, but I believe they will be. This lists all of the manufacturers and where they're located. And as you can see down here at the bottom, their total capacity, and again, this is based on throughput at the press, is estimated to be about 1.6 million cubic meters a year. And to give you a sense of what that means, a key metric is it takes about 22.5 board feet of lumber to make 1 cubic foot of mass timber. And so this chart shows like how much, if the total market is 10 million cubic feet of mass timber a year, that translates into 225 million board feet of lumber used. And in 2020, we used 282 million board feet of lumber. So, you know, we're right at the very front end. The market, mass timber hasn't really penetrated the market very far yet. But if it did get up to this, like say 640 million cubic feet of mass timber used, that translates into 14.4 billion board feet of lumber. And remember, in all of the US, we've been producing about 60 billion board feet for a long time. So that would be a pretty significant increase. And I mean, there'd have to be more sawmills built, and there'd have to be changes in forest management policy. But as far as I can tell, every year there's about 1 billion square feet of non-residential construction that's put into place in the United States. And this amount of mass timber would translate into about a little over 700,000 or 700 million square feet. So if mass timber the point of that is if this much mass timber was used, it would mean that mass timber would be at about 70% market share. And so I don't think, you know, I mean, that's pretty optimistic that mass timber could take that much share of non-residential construction market. And so, you know, this amount, 14.4 billion board feet of lumber usage, to me is probably like the maximum high end of what mass timber might consume as it goes forward. So I may have gone longer than I was supposed to, but I think I'll stop right there and turn it over to Lek, and I'll stick around and answer questions if anybody has any.
Okay, Roy, can you stop sharing? So, Roy, thanks for that. I think, you know, great presentation. You've kind of set the foundation, I think, for a lot of questions that we may be getting here shortly. I know I've got some questions based on what you've presented. Up next is Lech Mazinski. Lech is currently a professor in the Department of Wood Science and Engineering at Oregon State University, and a native of Poland. Lech received his MS in Wood Technology and PhD in Forest and Wood Technology from the University of Life Sciences in Poznan, Poland. And Lech, I apologize if I butchered the pronunciation there. Lech joined OSU in 2004. Since 2010, his focus area of his research has been cross-laminated timber technology and other mass timber panel products from around the world. Lech has toured mass timber production manufacturing plants, construction sites, focused research centers, and other places around the world to bring an international perspective to this discussion. And in fact, LEC joined the staff of principal authors of the Mass Timber Report this year, the 2021 report, specifically because we expanded the focus of the report from North America to international. So LEC, you're up next.
Thank you very much, Dave. Let me share the screen properly here. My presentation. Hope everybody sees my presentation. Very good. So thank you very much for the invitation to present in front of you, and thank you, Dave, for introduction. I'm going to give the talk a little bit more global perspective here. Roy's talk was focused on North America, and rightly so. We're in here, and it is of interest to us whether or not this technology is going to catch up and grow in this region. But I think the lessons are in what has happened in the other places in the world, and where we can look at similar or parallel developments. This is a little video that gives us an overview of a CLT manufacturing, more like a concept. It's not real manufacturing. You will see an animation that shows layers of dimensional lumber being put together. This would be like first layer perpendicular to the main axis of the thing, a layer of adhesive being put on it before the next layer of a dimensional lumber perpendicular to the previous one is being laid. And this process is repeated a couple times. At least 3 layers are required to call it a CLT. Otherwise, the product would not hold very well together. But in productions are 3, 5, 7, even 9 layers of panels that have 3, 5, or 7 or 9 layers in thickness, depending on the need. Now, these panels need to be prefabricated. Prefabrication means cutting out whatever necessary openings you need, ducts for utilities, as Roy mentioned. This is just one of the elements of a building. Combined together, they make the product, and the final product of the industry is actually not a panel, but a building or the access mat that Roy mentioned. So one consequence of this development is that what you receive is a panel of substantial size. So in meters, this may be up to 4 by 20 meters in planar directions, and about 18 centimeters. So altogether, one panel like this may be 14 cubic meters of lumber. This is substantial cost per piece as well. So quite often you may hear that the mass timber panel enabled prefabrication of houses. I think it's the other way around. Without prefabrication, it would not be possible to build with such massive panels. And you see that prefabrication is needed because to put these panels together, you need to have a ways of cutting, of fabricating the edges, cutting the windows and door openings and ducts for utilities that would not be possible with panels that large on the side of the construction. Now, the massive size of the panel makes it also quite safe in the case of fire. Here you see a 5-layer CLT panel after 2 hours exposure to fire, and it still holds a good portion of its original structural capacity. The fabrication also allows building at a very rapid pace. So this is one of the first tall CLT buildings in Moray Grove in London, England. Since there, many other buildings have been built, but this one is peculiar because it's all panelized. So both walls and floors are CLT panels. They carry load. They do not need any other superstructure. And here you can see its growth after the ground concrete layer has been put. And you see that the construction goes at a pace of 1 week per story of pretty complicated building. Now, in other construction, you could see, like in Australia, there was a 7 or 8 story building that was completed with a pace of 4 days per story. That's pretty impressive. And this is one of the ways where mass timber construction can potentially beat other construction technologies on cost. The world's largest timber building that I've checked so far, it's not necessarily the tallest, but by the volume of the mass timber panels used, is again in England, and it's called Dalston Lane. Now, this panelized construction prefabrication also allows shipping projects, not just panels, but projects, long way from the place where they are manufactured. My best example is in Australia, right here, right? There are a couple of companies in landlocked Austria that ship all projects fabricated, just ready to assemble, just half the globe away, and it still pays the money, right? Pays the money. So the models enable you something else. You can prefabricate entire model and deliver it to the construction site furnished. This cuts the construction time even more. And in fact, it's not just a concept. I visited a plant in Sweden where models like this are being fabricated like on a manufacturing line, like Ford 3 model, right? Where you have this assembly line in which these models are being finished and then shipped to the construction site. And what's next? Who knows? Well, actually, Emily knows, and she's going to talk about it next. Now, where is CLT manufactured? This is a map that shows most, not all of the manufacturing places in the world. It's becoming more and more difficult to speak about the plants individually, so we prefer to speak about them by regions. Now, if you feel sorry that there is no blob in here, I would like to tell you that just 6 years ago, US had no CLT manufacturer or no structural CLT manufacturer. And actually Oregon State University and some state grants helped this happen. And it was the first CLT manufacturer in the entire US here in Oregon that made news for the nation. The global industry output and capacity increases every year. Now, as opposed to the data that Roy was showing, this was the capacity calculated based on the press capacity. We collect data that mark actual output of the manufacturing plants, so how much they actually produce in cubic meters. So here you see the numbers in millions of cubic meters, and the growth is exponential, meaning it doubles every so often. We estimate that by now the global output is about 2 million cubic meters a year. The capacity, documented capacity, is about 1 million cubic meter a year. So is it much or little? Well, if this little blob represents this 2 millions of cubic meters that is produced globally in a CLT alone, right? You can see that the global output of plywood roughly in the same time was 160 million, so 80 times more. So the takeaway from this is that for now, for all the media chatter and all the excitement, the CLT industry or mass timber panel industry is still a boutique industry, very small compared to others. And it's in on its way of development. It's also very unique. It's a new phenomenon. It integrates mass timber design, manufacturing, and construction technologies because, again, it would be very difficult to produce these panels, as commodities and just wait for anybody to pick them and then cut large portions of this very precious panel for their projects. It is much easier to prefabricate all of this to produce panels to the size required, right? So the industry did not follow typical commodity-oriented forest products industry models. I'm going to illustrate it some in here. If this would be a typical supply chain for commodity-oriented engineered products or structural products like plywood, glulam, and whatever, it all starts, in harvesting, primary processing. This is what Roy was talking a lot about. You need to transport it. You have some industrial hardware, adhesives, and you produce your product. And then you just, you don't care where it ends. You just put it for sale, and it magically disappears from the threshold of your factory. Goes to Home Depot or to construction. So to illustrate it in a little different way, if construction is here and it's just one of the options, the manufacturer does not need to care where does it go and how it is being cut. This is all being done on site by people who fabricate the houses, right? Now, it is very different with cross-laminated timber or with massive timber panels, where the product is essentially the entire building. So the supply chain has necessarily to involve the architect. Now, architects become like the gatekeeper to the production. They acquire projects. Without them, nothing is being pressed in here. Engineers have to specify this. The CLT project management quite typically rests with the manufacturer, or if not, with a very specialized company like this one represented by Emily, who does not produce CLT, but they takes care of everything else in here, right? And then this is being transported to the construction site. Quite often companies have their own transportation means and they construct. So there are incentives for vertical integrations. Many things have to happen before you need to start, before you may start producing CLT. So many companies actually own part of the supply chain. They may have their own architect office. This is not very common, but happens. But very often they have their own engineering office and they provide the project management services. They transport panels to the construction site, and quite often, although not always, they also have construction crews. They also educate people along the supply chain and the clients about the product, and it's like big part of the activity. Now, some companies that started as previously producing something in forest products may also have integrated in their company this harvesting, primary processing, and log transportation things. So you see, this is very, very different, very much more complicated operation that you would have for a typical process. Now, I told you that rather than speaking line by line, it is easier to talk about regions producing cross-laminated timber. I would like to draw your attention to this region in Central Europe. This is where this entire thing started, right? In Austria, Switzerland, Germany, northern Italy, and a little bit in Czech Republic. Since then, the technology had been transferred to other European countries, which we consider different region, right? And to North America, and to South America, to Australia, New Zealand, South Africa. So you see, things are mushrooming out pretty quick. And if you take this global output capacity, this 2 millions, you see that the central region in Europe still provides a good 2/3 of the global output, right? The rest of European countries that produce CLT add this slice, which would be, the small additions here, outweigh the production in all of North America, which I find is pretty interesting, right? Asia Pacific, which we include like both the Japan, which has about 8 CLT manufacturers right now, Australia, which may have 2 pretty soon, and New Zealand that has 1. They produce this small sliver in here. South America, Chile and Brazil produce something, and there is 1 plant in South Africa. Now, by capacity, this would be like per shift capacity. And again, this is not the theoretical capacity. It is calculated based on the press capacity, but actual capacity of the plant. You see that things look somewhat differently, and the capacity of North American plants is chasing the European, but you can also see that this smaller per shift capacity translates to much better use of this capacity. They can work on 2-3 shifts basis, right? Which is a testimony to the efficiency of their project acquisition process and the familiarity of the building industry to the product. Now, these statistics here that I explained, they do not include other cross-laminated products that are not CLT. This is a nail bonded cross-laminated timber. It's been developed in Germany, so the brand name is Massive Holz Mauer, or MHM for short. It is made in 3 simple somewhat automated steps. First, like planing the boards. Then there is a robot that lays them up and adds aluminum fluted nails to this. This penetrates just 2 layers at a time. The aluminum layers are here because then the CNC center may cut through this panel without losing teeth on the steel nails. And these are being used for small construction, mainly for walls and ceilings. This product is not good for floors. Now in Switzerland, a new technology has been developed. You've heard Roy mentioning dowel laminated lumber. Now this is cross-laminated lumber that is bonded with hardwood dowels. And they can produce panels that are almost as strong as those made with CLT, where you bond them with adhesive. And they are being produced on specialized, highly automated lines. About 8 lines like this operating in Europe right now. And then, of course, there are other glueless options. There is 1 company operating in Utah is making this kind of like wood puzzle, but on large scale. These are large panels that are being used. They are not as strong as the nail bonded cross-laminated timber or dowel bonded cross-laminated timber, but still are being used in construction and look very beautifully. Roy has provided you already with the outline of the production line. So it starts with raw material reception, finger jointing, planning to thickness, separating, cutting to long and cross pieces, lie-up, pressing, and then machining and finishing. So I'm going to add some detail to this process. So first, if we focus on the raw material reception, right, this is where a couple of interesting things happen. Many companies, even though they trust the suppliers of lumber, they want to check again the grade and moisture content, which are both very important. As for species that go into CLT, there is no magic. Whatever is a commercial species in the country or region, it goes, right? Now, the dominance of the pine, of spruce and fir is just because you have seen that the Central Europe holds the majority of the production. So whatever, these are 3 dominant commercially available species in there. In North America, meaning in the US, in Canada, right? This is mainly spruce, pine, fir, larch, and Douglas fir. The typical lumber reception area would not differ much from any typical forest products company. Finger jointing is important because now these pieces come in random lengths, while you need a very specific length for your panel. The most efficient way is just to bond them all together in length with this finger joint, as you see it in here, produce virtually unlimited long piece of lumber that then you can cut to pieces according to your needs. The next important thing is planing. First, you want to get rid of all of these blobs that may make bonding, good bonding, very difficult. But also, when you cross-laminate timber, it is very important to keep a very tight thickness tolerance. So you would see that companies plane quite aggressively. I could see it only because they stopped. There was some problem with the planer, but with this you can see how aggressive the planing is. After that, the long and short pieces, if they were not cut in here at this step, they are being cut to length and separated. So the short pieces, the cross pieces as we call them, they start to travel separately, long pieces travel separately. And they end up at the lie-up and adhesive application station. This has to be combined because for each layer, as you have seen, of lumber, you need one layer of adhesive. Now, there are many options. There's no one way of doing this. I've seen operations that the entire layup has been done by 2 people manually, right? And others where it's highly automated and done by robots. So this would be one of the highly automated processes that I'm going to show very quickly. This is a bed on which the layup is traveling into the press. It's lined with Teflon. You don't want your big pieces to stick to the bed, to the tray, right? And then you have like vacuum conveyors. These are the suctions things that pick. This is the longitudinal piece being picked up. Now you see the beads of adhesive being deposited on this longitudinal thing. The same conveyor brings up the transverse layer. You see again a adhesive being put in between, and here travels the next longitudinal layer. And the entire panel, here you see a layup with 5 layers, travels into press. If you want to increase your throughput, you may go with 2 presses at the same that alternate, right? Now the pressing, it used to be that the presses have been fabricated or invented by each company separately, right? Now it is more and more typical. You see that here we represent just 3-4 companies that begin dominating the market of the hardware for CLT, and this would be Ledinek, Minda. For vacuum presses, there is one Swiss company, and Calso, a company that produces radio frequency presses. So as I said, they used to come in all sizes and flavors. These are examples of the custom-made presses. But quite often overlooked option is quite inexpensive vacuum pressing. In vacuum pressing, you see the presses look like a wading pool and have silicone blanket to cover the layup. And then when the vacuum is pulled, you actually press, you squeeze the panels together. That way you can put many dissimilar pieces into this vacuum press at the same time, which is an advantage. It is much harder though to automate the layup, unless you are like this smart German company that has this vacuum beds specially designed in a way that they can be stacked upon each other. And they have a automatic layup that is adjusted to this. Now, the next step is the CNC finishing. This would be like cutting the windows, doors, and machining the edges and so on. Again, this tends to be dominated by just 2 major manufacturers of the CNC machines. And this would be Handegger and Uniteam, which used to be, I think they changed the name, they merged with another company, Bise, Italian brand. And then there is a smaller German or Swiss manufacturer, Wiesmann. So now the important thing is, again, at the end of the pressing process, you have a very heavy panel. In order to move it towards this machining, you need to somehow install some kind of connectors, right, that will allow you just transport the panel within your manufacturing line. This would be the CNC machine seen from outside. Again, this is another example of transporting much larger panel. So this would be an example of this Uniteam gantry. Inside, it has robots, essentially, with all kind of wood cutting tools. So here you would see something that resembles chainsaw to cut the windows and doors opening accurately.
De cadena, y esto es para cortar con precisión y darle un terminado a los cantos. Hay moldes, hay cepilladoras y hay barrenas. Y pueden hacer mucho más que solamente hacer un corte recto. Aquí esto es algo que hemos visto en Suecia. Es un corte muy sofisticado que no es para un edificio, sino para una construcción como esta. Es para el metro de Estocolmo. Ahora, para el acabado de la superficie y para tener un grado visual y hacerlo más bonito, la mayor parte de los paneles se cepillan. La última etapa para la producción del panel, bueno, también hay
mundane step if you are doing commodity, but if you are doing projects, it is not so easy. It's actually quite sophisticated thing. Think about it that way. If you are assembling the building away from the manufacturing site, you need your tracks with the panels arriving in a very specific sequence. And even on the track, the panels have to be placed in a very specific sequence that reflects the sequence of assembly. So you can see the highlight of this. Here, nothing is being produced on site. So in the dumpster, you see only like the packaging and the wrapping ribbon, right? Nothing else. The construction is very quiet and fast. So this is why it's actually the manufacturer's responsibility to take care of how these things are being prepared for transportation. Here you see complex project. All of this represents one project, but is divided into daily or into deliveries. And all of this needs to be timed. It's a very logistically complex procedure. So if we dare to have a little summary in flight, there is incredible diversity in the manufacturing process and market strategies of the companies. They vary in their capacities from as little as 500 cubic meters a year to as much as 100,000 cubic meters a year. And bigger steel lines are coming up. Now, owners vary from family enterprises to big international holdings, for which the manufacturing of CLT is just one of the many things that they do. The manufacturing processes and level of automation vary greatly. However, these new lines that tend to be high capacity and highly automated, with option for a company that produces the hardware to deliver the entire turnkey integrated line to the investor. About 75% of all presses installed are made by one of three specialized, or four, I should turn it into four specialized manufacturer of the hardware. Companies are upgrading and adding lines, boosting capacity and looking more alike because of the specialized manufacturers. There is no signs of CLT or mass timber panels becoming commodity, like being sold, by panel somewhere in Home Depot or delivered blank to the construction site. MHM and the dowel bonded cross laminated timber are rise as complementary product. They do not really compete with CLT. They are complementary, and they see a big growth. 20 years since the invention of CLT, this industry is still very young. It's still looking for its way. So Mexico is not too late to join by all means, and who knows, some new ideas may come out from this development. And I would stop, and we may talk more about it during questions. Although I believe this is not the question session yet, I'll be transferring this to Emily. Thank you.
Hey, Lech, thank you very much. Appreciate that. A ton of information. Very, very interesting stuff. So thank you for that. Next up is Emily Dawson. As I indicated earlier, she's a partner and a principal architect at Kaiser & Path in Portland. Emily has been investigating and implementing mass timber solutions for nearly a decade, including designing the first cross-laminated timber structure built in Oregon. At Kaiser & Path, she works exclusively on mass timber projects from feasibility through construction. Emily is one of the 3 principal authors, I think I may have mentioned earlier, of this year's report. She also contributed to last year's mass timber report as well. So Emily, your turn.
Hi, everyone, and thanks, Dave. I am going to dive into some case studies of the buildings that we've done and why we think that mass timber is a great option for real estate development and market viability. I'm going to start by talking a little bit about some of the things quickly that some of the other folks have run through, but just kind of from our perspective. The building industry has an energy and a carbon emissions problem, as Dave laid out so well at the beginning of this presentation. And we have looked to wood to solve that embodied carbon problem in our buildings. And embodied carbon, I'll go a little bit into why that's so important in terms of how we think about energy use in buildings. Oftentimes we think about it mostly in terms of operational energy, definitely for the last decades or so. That's been more the focus, and our focus is now shifting to embodied energy. So our company is a little unusual. We are architects, but we are also developers and contractors. So we also are the owner and we build our own projects. And that means that each decision that we make as a holistic team. So we are able to make fast decisions and take on a little bit more risk than a typical owner structure might. As a result, we were able to do some pretty innovative buildings and take on mass timber before it was really allowed by code. And the state of Oregon was very supportive of this because of the potential of mass timber to revitalize Oregon's timber economy. And so the building that you see in the center at the bottom, in the bottom row, is Carbon 12, and that has been the tallest mass timber building in the country until very recently. It was just passed by a building in Milwaukee, which is very, very exciting. When that building is complete, it will be the tallest in the country. But we did this building before the codes allowed it to happen. So we are able to make decisions like that because of the structure of our team, which is a little bit unusual. We choose mass timber because it makes sense for us economically, because it's a wonderful product on the market. And I'll get into that with some of our case studies, but we also choose it because it makes sense for combating climate change, and it's an environmental solution, which is to us the most important problem of our time. And I think at this point, a couple of years ago when I first started showing this slide, it felt a little bit more important to illustrate. I think all of us now have this sort of in our hearts as a truth and a reality that we're living in a very unprecedented time in terms of atmospheric carbon, and there's something that we as a species can do about it. When we look at the building industry, this is a little bit different chart than Dave showed earlier, simply because of the way that concrete and steel are separated out in this chart versus his. So, but what I like about this is that it shows what the embodied carbon piece of that pie is for the building industry. So 11% of all total carbon emissions are what it takes to just simply build the building before it even opens. And 80% of that 11% is in the structure. So when we look at replacing traditional materials like those high embodied carbon materials of concrete and steel with something that is bio-based, we are really taking a significant portion of that embodied energy and solving for it. Globally, cement and steel produce together about 10% of global carbon emissions, and that is throughout different sectors, but it is really impactful to start to reduce our dependency on those materials in buildings. And when we talk about timber, we talk about forests, which is sort of this wonderful connection that we all have as human beings to the forests. And as if you're living on the west coast of North America, this has gotten more and more and more clear. Our relationship to the forest is very critical, and the management of our forests is something that we're all thinking about, whether you're in the building industry or in the forestry industry or not. The photograph is from last September in Oregon, where we had the worst wildfire season we've ever had, and the air quality, which is the picture on the left, is an air quality photo that shows the worst air quality in the world, kind of ever. And it was really traumatizing. I bet, depending on the way the winds were moving at any given time, some of you in Mexico probably saw some of the smoke. I know some folks on the East Coast of North America experienced it as well. So we have this really wonderful opportunity because of the place that we are in history to look at our forest practices and do something about it. And mass timber, of course, sees that opportunity as well, and in using salvage material efficiently, potentially. Because I'm not a forester and that's not my area of expertise, I would encourage you all to check out this TED Talk, a forester who works out of Oregon. And he really lays out an interesting commentary on why forest management practices have kind of led us to some of this overstocked fuel laying around in our forests, and why density is not necessarily a good thing in forests. And one of the things I love about this presentation is that he points out that a lot of the practices that were happening before colonialism, before settlement of North America by Europeans was happening, the forest practices did a lot of things that we are starting to implement more now, like thinning and prescribed burns. One amazing resource that I've been going to think about what may have been happening on the landscape before industrialism came and overlaid over the forest is a map that looks at pre-colonial settlements vaguely, like what boundaries could you possibly sort of draw. And you can actually look by zip code at this map and find where you live and look and see so this is Mexico City, and you can look and see who occupied the land before industrialism, and then go research what maybe their forest practices were, or their relationship to wood in general. Did they build with it? Did they cook with it? And start to understand a little bit more about how we might be informed by ancient practices. And we also have these wonderful tools of our new industrial age and industrial practices to do things at scale. So we'll be able to implement, kind of combine these two sensibilities and implement them at scale in the coming decade to hopefully solve for climate change and atmospheric carbon. So going to the idea of a circular economy is also, I think, really important. When we think about making a building and using a bunch of resources, we want to start moving toward a waste-free process of doing that, which another way of saying that is a circular economy. And we can think about that in terms of carbon too. If we're not expelling more carbon than we're absorbing, then we have a circular carbon economy. And then there's also that idea of a bioeconomy, which the globe sort of does on its own, right? It's a natural process is a circular bioeconomy. And wood fits right at the nexus of all of these concepts, which is a really beautiful way to think about it, I think. One of the reasons why this mass timber especially fits into that concept is because of the reuse potential for it. So because it's made out of these massive pieces, very, very valuable, as Lek pointed out, these are very, very valuable pieces of wood. They're easier to disassemble and reuse potentially. So keeping that wood out of the landfill and making sure that it doesn't decompose and go back into the atmosphere is part of that idea of a circular economy. So we're starting to think as designers more about a design for reuse or a design for disassembly outcome at the end of the life of the building. But hopefully these buildings stand for at least 100 years or more because they're so beautiful and they're so durable as well. So when we think about designing a low carbon building or a carbon sequestering building, there's a long list of things. It's not just about the structure, but when we look at using products like cross-laminated timber, it starts to check a lot of these boxes. And that's because of the sequestration, but it's also because of the overall efficiency of the process that you start to see kind of driven by the modularity and the precision of these elements. There's fewer waste, less waste. And when you're designing in modules, you tend to, that reduction in waste tends to ripple out into other materials as well. We're able to use less concrete, able to use less steel, and really we're able to use just less of everything. When you can use the structural material as a finished surface, you are necessarily reducing the amount of furring or gypsum board or paint in the building and reducing your overall footprint. You'll have this resource by the end of this presentation. And I usually talk about this because this is such a great opportunity. I love working with Roy and with Lek because we're able to look at the entire supply chain together. And so we can ask big questions about capacity and the market. And I think Roy went over this really well. So I'm not gonna spend too much time on this, but there's just a lot of potential for complete market saturation in the building market because of the capacity of North American forests. And there's bottlenecks around labor and machinery and all of that, but so there's a lot to do to get there, but the potential is there, which is really, really exciting. And we're seeing that growth. And I think Lek had a great diagram on this too about the production, and global production is really showing that exponential interest in CLT and mass timber as a building product. So getting into some of our projects, the Radiator is our first mass timber building. We completed this building in 2014. It was actually a pretty old-fashioned approach with glulam post and beam structure with tongue and groove decking. So this is the kind of building that you'd see built a lot about 100 years ago in industrial sorts of circumstances. But it's this along with the two other buildings in the development was the largest mass timber development in about a century in Oregon, if not sort of a larger scope than that. And we had so much success leasing this building. We were able to secure tenants, key anchor tenants for this building before we even broke ground. And that was because we took them to the Bullitt Center up in Seattle, which is another mass timber building that was built, that had just been completed. And they saw the effects of the wood in the space and thought about their tenants and thought about, this is a health clinic. They thought about the people coming to find wellness in this space and understood that the health and productivity benefits of being in an exposed wood environment were just so valuable to them. So we leased up the entire building 6 months faster than our pro forma assumed, and we only had one tenant turnover before the pandemic happened, and then there was a little bit more turnover, but not based on more than the economy being strange. We actually sold the building before then, though. We had an unsolicited offer to buy the building a few years ago, and so we did. We actually have our office is in this building as well, so so we do see and feel the benefits of the mass timber space every day. Carbon 12, as I mentioned, is a building that we built before the code allowed an 8-story building or a building of this height. And we were able to permit it through the state of Oregon, so we didn't go through our local jurisdiction, which now we could do that. So the path that we took was a little bit different than we would if we were building this building today. It took a lot more research and development and time to approve. So the building is a luxury product. It's a luxury condo building with 14 units, 2 per floor, and each unit has its own elevator access point. So we have one elevator core, and the elevator opens up in both directions to go directly to any given unit if you have a key. And so that was a product that we needed to put at that price point to cover all of the R&D, the research and development costs to make this project pencil out. But what we learned when we were building this project is that it went up so smoothly. And when you can take risk out of construction, that is hugely valuable. That's something that eventually banks will learn and insurance companies will learn. And so those premiums will start to match the reality of the risk reduction that we do really see in constructing a mass timber building. You can see in the center of our building is a steel buckling restrained brace frame core that was also manufactured offsite. So we were able to drop that in with the crane 3 stories at a time, and then each floor, and we started at the ground floor with timber in this case. There is no concrete podium here, and every floor went up a week at a time. And I think we could have gone a lot faster, but again, this is it was a new technology at the time, and the installers hadn't used it before, so we were being careful, but everybody was really happy with the fact that we didn't have to modify any pieces on site. So an entire wood frame building with no field modifications, very quiet, as you could imagine. You don't have the saws going as you do sometimes with a framed building. And the construction crew on site here, you can kind of see if you look closely, it's very small. There are 4 people on site here. 3 of them are on the building and 1 of them is in the crane. So very small crew, very fast construction time. And a lot of that has to do with our investment in higher end, very, very quick connection points. So these are a couple of different kinds of connections. You can see on the left, a column with a column to column connection. That's a floor to floor connection that just kind of slips in, and that's custom. We had that fabricated specifically for the project. And then on the side of the column, you can see an off-the-shelf fastener. At the time, we could only get these out of Europe, so we had to do some special testing for it. That is a connection where the beam can just slip onto the column very, very quickly, and that it's a little bit higher end. So if you're pricing out a system like this, you're going to see some higher unit costs. And so as you're estimating, you absolutely have to go to the construction schedule at the same time and make sure that you're taking into account the reductions there. One other thing that we really learned when we were building Carbon 12 was that mass timber can be put up in pretty much any weather. You're not going to see a lot of snow down in Mexico, maybe at higher elevations sometimes, but we had the snowiest winter in Portland that Portland had seen in a long, long time, the winter that we were putting up this building. And if it were concrete, we would have had to halt construction for weeks because of this cold snap. As it was, because there's no temperature requirements to install cross-laminated timber, we were able to only lose one day, and that was because people were not able to drive to the site that day because of the road conditions. So we estimated that we saved over 3 months of construction time overall, considering the potential delays, than if we had gone with a concrete building. And that was an estimate from our concrete subcontractor. We have a resource that we put together with funding from the U.S. Forest Service. So if you have any questions about this building, and we've gotten tons of them, we kind of collated them and put them all into this resource that's available online. So please go check that out if you have any questions. So this is the picture of the finished space. And I like to show this one just so we can all sort of sit here and appreciate the precision of this beautiful structural exposed structure in a luxury condo unit, which is just something that has been more of an industrial feel in the past when you're thinking about a concrete building, but now we can actually have these luxury spaces and not add all those extra materials that you need with other construction types. So I mentioned before, we're an integrated team of designers and contractors and owners. When we think about the cost of the building, it's very important to do that. You have to have a cost estimate, but we're also thinking about the value of the building and how it's going to perform on the market as a product. So when we look at the cost estimate, we're also thinking a lot about construction duration, which if you can reduce construction duration, you're reducing risk simply because you're not, you don't have to confront things like pandemics or forest fires or weather. The pandemics and forest fires weren't something that we foresaw, but that was something that affected our last construction project. We're also thinking about loan rates and when we can start paying back those loans. We're thinking about leasability and leasing rates. At what rates can we start to sell or lease these spaces? And then what is the market value at sale and how long do we want to take to try to sell this building? And market differentiation is a really important part of thinking about a lot of those components. So I'm going to take you through a little cost exercise that we did on the Canyons, which is a building that we completed last November. It's a 70-unit apartment building. This is a market rate apartment building. So we were able to take the price point way down from the luxury product down to a market rate product. This is a 6-story building. It is a very straightforward, from a code standpoint, type 3A building over a type 1A podium. So we do have a concrete foundation, basement, and first floor podium. And otherwise, it's very straightforward. We have CLT floors and roof and light framing for our shear walls and our non-load bearing framing in between. We have also an unusual corridor situation. So it's a double loaded corridor floor plan, but instead of having a typical corridor, we have a 5-story atrium space where we're really featuring those CLT panels, and the idea is sort of to compound that biophilic effect of seeing wood and feeling wood, with also bringing in light and air. And as we learned in the pandemic, this is actually kind of a wonderful natural ventilation feature that our tenants, as tenants are starting to move in, they really value that. So it was kind of a lucky coincidence in that way. On the left in the picture is a ground floor retail area. That's another unique feature of the Canyons. It's an alley with micro retail units. So small spaces where small businesses can come and support each other with traffic. So it's been exciting to see folks start to move into those spaces as well. So when looking at the picture on the right, I'm going to take you to the floor plan, but you can orient yourself by looking at the corridor in the middle with that atrium space and those skewed panels. So starting to get into that cost exercise, I'll explain first how the building works structurally. The CLT, we have 2 different thicknesses of CLT towards the core of the center of the building, where we have more services and more soffits. So the yellow that you see there, that I've highlighted all of the soffits where we've dropped the ceiling down. We have used gypboard and framing to conceal utility lines, fire sprinkler mains and plumbing and electrical and all the things, all the services that you need to run through a building. We also have more load-bearing walls along those smaller spaces. And so we're able to actually reduce the thickness of our 5-ply panel in those areas because they're only spanning about 10 feet rather than 20 feet, which they are at the exterior. So we have the thicker 5-ply on the exterior side of the building. We were pricing this building in 2018, and one of the things that surprised us in 2018 was a bunch of new tariffs in our country. And that put us into a cost savings exercise that had us, despite our deepest wishes, had us looking at potentially switching the entire building to a light framed solution. So moving from just completely deleting the CLT package and using I-joist framing, adding back in drywall and all the soffit framing, the paint, the labor, and then the schedule as well. And because our contractor that we were working with, we actually partnered with a contractor for this project, they would have panelized all of the floors. We actually only added 5 weeks to the schedule for this building because it would have gone up kind of quickly, even if it were completely light framed. So when we did this exercise, what we found out was that we would get a savings if we went to light framing. We would get a savings in capital costs of almost $400,000, which for a $22 million building is significant. And we had to take it into consideration, despite not wanting to in our hearts. But then we went to our CFO, who is familiar with the carrying costs that we were incurring on our loans and other fees that we were paying as a developer. And the increased 5 weeks would have cost us $100,000. So that immediately takes a bite out of that savings. So then, we'll look at that $278,000 savings then. So now we need to take the next step and look at what does that mean from a leasability standpoint and a differentiation standpoint? What is the value that we're losing in this building if we go completely to a softed situation? So the reason that it's all highlighted yellow now, no more wood ceilings, it's all gypsum board and paint. So our lease rates go down a little bit, which means that our monthly returns go down as well, and our annual returns start to go down pretty significantly. It's almost $100,000 a year there. So if you translate that into a payback period for a premium building, then you're looking at really only a 3-year payback on a premium asset, which makes it a lot more easy to sell. It makes it easier to lease. And the value at sale impact at year 0, and so that goes up every year as the building matures, is $1.7 million. So it really is important to look at the value holistically when you start to make decisions as a design team and as a contracting team and build team about whether it's really worth it to take those value losses. I think I did a square footage estimate on this too. So, if you back out and say, well, how much per square foot am I really paying for that premium wood ceiling that I want and that higher ceiling, because we would have lost some ceiling depth as well. It ended up being about the installed cost of carpet. So it was just for a really low cost, material cost premium, we're getting a very high value building out of it. So we chose to keep the CLT in the project, and we chose to keep that reduced soffited area because of all of the reasons that I just said, but then also because of that really the biophilia is that value. So we're starting to be able to put numbers to that as we are able to get more data on leasing rates and sell rates on our buildings. Couple pictures from the construction process. Our team found again that this process was just really smooth. You can see Carbon 12 in the background here. This building is just right next door. So if you're ever in Portland, it's kind of a easy tour to go through on one block, and our office is actually just a block over there too. So we have a little mass timber campus going on the corner of Williams and Fremont in Portland. A couple of pictures of the completed units. You can see just how special those spaces are, and imagine with those almost 9-foot ceilings, just how expansive and warm those spaces feel. I have a video of our concrete podium being poured, which is the same footprint as the upper part of the building. So on the left, you'll watch our concrete going in, all of the formwork required, and then on the right-hand side, you'll see our framed walls starting to get stood up to support the 4th floor of CLT going in. And we're calling this a race because it's the same footprint. How fast can you build with concrete? How fast can you build with wood? So we have, the formwork is starting to get finished up on the concrete side. You can see how many people are working on that as well. I mean, there's just dozens of people scrambling around on the site. Over on the right-hand side, you have a much smaller crew, and they are almost done with the floor. They have completed the CLT installation. Right on the other side, we have rebar going in. We have the post-tension cords going in, getting ready for that pour. So lots and lots of folks, lots and lots of materials, lots of time, of course. And I think we're about to get to, here comes the concrete truck. About to get to that pour. The pour itself goes quickly, taking dozens and dozens of people to do. And then of course it has to cure before you start loading it as well. So that's something that doesn't show up in the video. But just installation, we have about a week of savings on this wood side. So thinking back to the 3 buildings that I just showed you, what does that mean in terms of carbon sequestration? If we just look at the CLT package and the wood packages in the building, so not thinking about the entire building itself, but just the wood part, and what is that sequestering? Total of those 3 buildings is about 800 tons. And to me, that's very hard to visualize. I'm not really sure what a ton of carbon looks like. So I like to think about it in terms of the forest that I'm familiar with. And all forests are going to have a little bit different profile, but the Pacific Northwest forest is very carbon rich. And so it's equal to about 8 acres of living forest in the Pacific Northwest. But when we think about a forest, it's only part of the forest that we're extracting to produce dimensional lumber and to produce mass timber. The trees itself are sequestering a lot of carbon, but there's a lot of other things in the forest that are sequestering carbon as well, mostly the soil. So we're extracting, when we harvest trees, we're extracting them, and then we're using about 9% of that mass to produce timber with. So I think it's really important to realize that the forest is a lot more than just the trees, and the trees are a lot more than just lumber. And that product coming out of it, it's really important to treat it very efficiently because it's a valuable resource and it's part of a very complex ecosystem. I wanted to show this too because this is in the United States. The development of the codes has just been fascinating, rather unprecedented in an architect's life. To have a completely new construction type in the code is very exciting. So our type 4 heavy timber now has 4 different subtypes in it, which allows buildings to go up to 18 stories. And the 3 different types are different levels of fire resistance. And in this case, built into the code is encapsulation of that timber with non-combustible materials. And what that means is that the higher you go, if you go above 12 stories, if you go above 9 stories to 12 stories, you're encapsulating about 30% of that exposed wood. If you go up to 18 stories, you're actually encapsulating 100% of that exposed wood if you go with a prescriptive path. So if you think back to the value exercise that we just went through, that really starts to break down the value proposition of a mass timber building if you completely cover it up with combustible materials. So what I think is going to happen is we're going to see more innovative performance-based buildings, which can look at the combustibility of timber and model flame spread and smoke spread and show jurisdictions through a performance report in jurisdictions that support that approach, that mass timber buildings are safe at taller heights without that encapsulation requirement. So I see that as a really promising next round of research for our industry. And what we're going to be working on in the meantime is the price point and getting to affordability. We were able to do a luxury product. We were able to do a market rate product. Now, how do we do something that can help solve our housing crisis and our affordability crisis in the building industry? So again, right now we are funded by the U.S. Forest Service to ask these questions and try to come up with some solutions. So it's just so great to be here with you guys. If you have any questions, looking forward to your questions. On the right hand side here are the resources that I mentioned during the talk. So thank you so much.
Thank you, Emily. Appreciate it. Tanya, I know we've used up our 2 hours, I believe. So I'm not sure, do you have time? Does the audience want to stick around for some questions? Or as an alternative, perhaps we can collect up those questions and try and answer them offline. At this point, it's up to you. Looks like you're on mute, Tanya.
Sorry about that. Let me ask, Manuel, ¿tú qué opinas de quedarnos, o sea, más tiempo? ¿Crees que haya preguntas o si tienen preguntas que nos quisieran poner o si nos los quieren mandar por correo? ¿Alguna pregunta que tenga alguno que nos
Tania,
quieran poner?
las preguntas se me imagino las van a enviar por chat, ¿no? ¿Ok?
No, o sea, bueno, si quieren ahorita, o sea, podemos contestarlas o si ya tienen, o sea, otra presentación, pues, si no, nos las pueden mandar por correo y nosotros las podemos contestar.
Una pregunta rápida porque ya se nos fue el tiempo. Ha despertado mucho interés el CLTEC México, pero aquí en México no hay distribuidores y en algunas obras que están saliendo en Riviera Maya se buscó contacto con empresas de Estados Unidos y lo que les cotizaron fue muy caro y terminaron creo que se hicieron por comprar en Europa, no sé en qué parte, ¿no? No sé cómo andan en precios o si tienen un listado de distribuidores CLT y del Glulam de viga laminada. Más que nada solicitó de información.
Ok, perfecto, Manuel. También tenemos una persona levantó la mano para una pregunta. Arquitecta Diana.
Sí, así es. No sé si me escuchan bien.
Sí.
Ok. Toda la información definitivamente es muy, muy interesante desde el inicio, la emisión de carbono en todos los procesos, como lo que acaba de exponer Emily, de todo lo que se ahorra tanto en proceso, recurso humano, recurso material. Sin embargo, como bien dice Manuel, aquí no hay una ni distribución ni información. Sin embargo, México tiene muchísimo para producir y llegar a esos puntos de poder suministrar todo lo que es la demanda para ese tipo de obras. Entonces, a nosotros en la parte que es constructiva, nosotros como arquitectos, tenemos mucha inquietud por este tipo de nuevos procesos. Sin embargo, temas incluso de capacitación, creo que no hemos podido tener acceso. De hecho, mi principal pregunta ahorita es si la información que ahorita nos están exponiendo nos va a llegar por correo. De hecho, ya me metí a la página de Carbono, Building Carbon 12. Está bastante interesante toda la información Kaiser plus PAT. Igual la información está muy, muy amplia. Sin embargo, hay mucha gente que nos pregunta sobre estos. Thanks, Emily. Hay muchas personas que nos preguntan de este tipo de proyectos y en efecto, como dice Manuel, lo cotizamos, pero como no hay aquí alguna empresa que trabaje, que tenga esa línea de producción, como también en la anterior exposición, se vuelve muy caro simplemente por temas de aranceles, no por el producto como tal. Entonces, el arancel sube el costo que en algún momento nos pudiéramos nosotros aquí ahorrar en temas productivos. Entonces, ¿qué tanto es viable, tanto ustedes como empresa, el poder poner aquí en México o el ver algún desarrollo de proyecto en el cual se pueda aquí hacer una maquila de todo ese tipo de productos? Porque el consumo, la demanda, la solicitud, la inquietud, el material, la materia prima lo hay. Entonces, número uno, esa es la pregunta. Si van a mandar la información por correo y de qué otra forma podemos, en caso particular, acceder a más capacitación. ¿Cómo aquí como arquitectos podemos ofrecer más el servicio con la seguridad de tener costos, parámetros, todo eso que sobre todo mucho me interesó lo que Emily platicó desde el ambiente mismo que hace la madera, el que es termorregulable incluso, es importante para todas las personas que se les pueda dar a conocer y que sea ese plus a su proyecto, al trabajo, a todo lo que realmente están invirtiendo. Entonces, pues ese es mi comentario. Gracias.
Muchas gracias, Dana. Okay.
Yeah, if I might step in here real quick. First of all, I think there was a lot of questions there. I wasn't following it entirely correctly, but I think there was a lot of questions there. We can certainly dive into that a little bit. I do want to check with the panel and make sure you guys all have some time to stay for a minute. Okay, so, but I would like to suggest that, yes, there is a lot of educational materials available. We can direct you to where that information exists and resources for that, and we'll certainly be happy to do that after this session is over. And I would encourage you to maybe collect up any other questions that might come your way and send those to us, and we'd be happy to tackle those offline. But for just real quickly here, Lek, I think maybe you've got some comments on some of the questions that came out of that.
Yes, so let me start with this. Before structural CLTs was ever produced in the US, most the first structures made in CLT were built with the imported panels from Canada, or quite often from Europe, because they were less expensive than Canadian ones, right? And again, the efficiency and the experience of the European companies makes them very competitive in overseas markets. I gave you the example of Austrian companies operating in Australia. They are still good at it. So this is first thing. It creates interest. First demonstration projects in a country, they generate the interest and perhaps mobilize lobbying partners to try to create a more amiable atmosphere or amiable environment for this type of construction in the country. Codes, standards have to change in order to allow certain types of structures. The other comment I would make is that starting a CLT manufacturing is a relatively inexpensive proposition as compared to starting a plywood mill or OSB mill that may go in hundreds of millions of dollars to start. Fully automated CLT line may be within the range of 300 millions. And if a company has already a glulam operation or sawmill operation, then a certain portion of the manufacturing hardware is already in place. So it's not as difficult to create domestic production as it seems. The technological threshold is relatively low these days.
Just a real quick comment, then I'll invite Emily and Roy to weigh in. But you made the point of European product being shipped to Australia. But if I'm correct, and certainly you guys correct me if I'm wrong, but two of the highest profile projects in the U.S. right now, the Intro project in Cleveland and the Ascent project in Milwaukee, are both importing their mass timber products. So please don't be afraid of using mass timber based on U.S. pricing. particularly right now. Roy touched on the cost of wood and the impact it's having on mass timber. There are plenty of ways to get mass timber if you want to build with it. So Emily, I think you had some thoughts.
Yeah, I just wanted to speak to how to start as a designer in this arena, and definitely there's some amazing online resources I put in the chat, but just to think about it from our standpoint in Oregon, we received a lot of mentorship from folks who'd been starting to use the material in Canada for a while. And so, you know, we talked to architects there, we did tours, we talked to contractors, we had contractors coming down to do installations and to mentor contractors. So there's a really strong mentorship relationship there from British Columbia down into the Pacific Northwest. So I would just encourage Mexican architects to think about it from that perspective as well, just that the work that's going on in the US is a resource in and of itself, and then there's mentorship opportunities to start to work together and partner and help build that expertise in Mexico.
Roy, do you have any thoughts? All right, so, you know, and maybe this would be a way to close as well, but I would encourage you all to think about the International Mass Timber Conference. You know, once a year we all get together. These are the leading people in mass timber world from around the globe get together. This year it was virtual. Next year we hope to have it in person in Portland. It's a great resource. It's a great place to come to network and to get introduced to all of the major players and get lots of information in this arena. So, you know, please take advantage of that. Reach out to us and we'd be happy to talk to you about that. Tanya?
Perfect. Well, thank you very much. I am going to send the questions. Si alguien tiene alguna pregunta, por favor, me la podrían mandar por correo electrónico para que se pueda ser contestada. And if I have some questions, I will send it to you. Thank you very much, Emily, Roy, and Lek. Thank you very much for the presentation. Also, David, thank you very much.
Thank you.
Bye-bye.
Bye-bye.
Thank you for the invitation. Thank you.
Thank you.